Good morning, students. Welcome back to the class. Today, we'll be going to discuss regarding one of the important classical problem of synchronization, which we call it as producer-consumer problem. In the last class, we have discussed it regarding bounded buffer problem, right? In the last class, we have seen regarding a bounded buffer problem. So what do you mean by a bounded buffer problem in the sense it is only applicable for only two processes. So by making use of a critical section, like it is going to, it has solved all the three problems of critical section. What are the three problems in the sense? Mutual exclusion, progress and bounded weight. But what is the drawback of that bounded buffer problem is it is only applicable for only two processes, but it is not at all applicable in the real world environment, right? Like we used to have many of the processes. So what is the thing we'll be going for move on in order to overcome that drawback is like we'll be going to have the producer consumer problem. Like here we'll be going to have multiple processes. Like when it comes to the bounded buffer problem, we used to have only two processes. Like among the two processes, how we achieved synchronization in the sense by making use of semaphores. Like we have achieved the synchronization by taking the weight and signal, by taking two semaphores, weight and the signal, weighting in the sense decrementing by one, signal in the sense incrementing by one. So by using that semaphore concept, we have achieved synchronization between the two processes. The drawback of that bounded buffer problem is like it is only applicable for the two processes only. When we are going to have many number of processes, this bounded buffer problem will not be working. So in order to overcome that, we have another solution for this critical section problem, or this is also called as the classical problems of synchronization, which we going to discuss today is the producer consumer problem. Let me give you a brief introduction regarding this producer consumer problem. As we all know, producer in the sense the one who is producing the items, right? So if we are going to produce any of the item, so the one who is producing that item, we call him as a producer. And the consumer in the sense the person who is going to use that item which is produced by the producer, we call it as a consumer. So here today we'll be going to look after the producer consumer problem. So here I'm presenting you the overview of this producer consumer problem. So once when you are going to start this producer consumer problem, you have to keep in mind three things. Fine. So you first of all you have to keep in mind three things. First thing is, before producing an item, before producing an item, the producer should check the buffer is not full. That means overflow shouldn't be there. When producer is producing an item, the buffer should be I'll be telling you. Uh, so here we'll be going to have this producer consumer problem. So today we'll be going to use this producer-consumer problem in order to have the synchronization. So this is the buffer, fine. This is the buffer. So this buffer is here producer will be there. He is the producer and he is the consumer, right? So producer and consumer, two are the persons. Here two persons are there, right? We call him as producer and we call him as consumer. So this we call it as a buffer. So here you have to make note that this buffer is shared among this producer and consumer. So this is a shared one. This buffer is a shared one, shared between producer and consumer. Fine. This is the buffer. So which is shared or common between the producer and the consumer. Right. Here, what the three things you have, you will be going to come across overflow, and second one is underflow. So these are the two things you will be going to coming across, overflow and underflow, right? So what are the three things we have to consider in producer consumer problem is, the first thing is, when producer wants to produce an item, if producer wants to produce an item, he has to check this buffer. This buffer shouldn't be overflow. He has to check the overflow condition. Like overflow in the sense the buffer is full. Overflow in the sense the buffer is full. So producer can't produce the items. Is it not? Like suppose like we'll be going to have a rack. In that rack we can keep only 10 books. Fine, for example, in that rack we can keep only 10 books. Okay, already 10 books are there. If I want to keep any another textbook in that particular rack, will it fit? No. Why? Because it will overflow. Overflow in the sense it will not fit, and it exceeds the limit of the rack. So that we call it as an overflow. So when a producer wants to produce an item, like he has to check whether this buffer is full or empty. Full in the sense overflow, empty in the sense underflow. Fine. When producer means producer is going to check for overflow condition, and consumer is going to check for underflow condition. Underflow in the sense that means zero. No items are there in the sense it is zero. So the first thing is, if producer wants to produce an item, he has to check the buffer first. If the buffer is empty, if the buffer is empty, or any one of the slot is empty, any one slot is empty, then this producer can produce the items. Fine. This is the first thing. So before producer wants to produce an item, this buffer should be empty, or any one of the slots should be empty. Then only he can produce one of the item. So that is the task we are giving for the producer. And what is the thing we are giving for the consumer is, if consumer wants to consume, he has to check for underflow. Underflow in the sense zero. If no items are there in the buffer, how can a consumer consume the items? No, right? Like as we have seen the example of a rack, if 10 books are there in the sense, like I can take any one of the book. If no books are there in that rack in the sense, I can't take any of that operation. I can't take any of that particular thing. So that is the thing we'll be going to check over here. And third thing is, like both this producer and consumer, both this producer and consumer should not attempt at a time. Should not attempt at a time. Fine. These are the three conditions we have to consider and we have to keep in mind when we are going to deal with the producer consumer problem. Fine. I think you got the concept, like producer and consumer. What is the task of the producer in the sense? Producer wants to produce the items and consumer purpose is to consume the items. So what are the three things we have to consider is, if a producer wants to produce an item, he has to check whether an empty slot is there in the buffer or not. If the buffer is full, the producer won't do any operation. Why? Because he can't keep any another single item onto the buffer. So he'll be going to in a sleeping mode. If consumer wants to consume an item, he has to check for underflow. That means any if that buffer should not be zero. Either one item is there, he can consume the items. But if no items are there, he can't consume the items. So these are the three conditions which are very important when we are going to deal with the producer consumer problem. So this is the basic funda of this producer consumer problem. Now look at here, producer consumer problem. This problem describes two processes, producer and consumer, who shares a common or a fixed size buffer. So this is a fixed sized buffer is the common between the producer and consumer. It is a common between producer and consumer. So this is the, like, if any common thing is not there, then there is no, will be not getting any of the problem. When we are getting the problem, in the sense, in the cooperative process only we are getting the problem. Cooperative process in the sense, so anything is shared among the processes, we call it as an cooperative processes. Independent processes in the sense, that is of independent, individually it will be going to do the task. But when it comes to the cooperative process, when we are going to say that the processes are cooperative, in the sense they are going to share something which is common among all the processes, then those processes we are called as cooperative processes. So here, what is the task of the producer? The producer job is to generate a piece of data, put into the buffer and start again. That is producing items only. If he produced one item, that item he'll be going to place in the buffer, and again he'll be going to produce another item, he'll be going to place in the buffer. Before placing on to the buffer, he has to check whether the buffer is full or not. If the buffer is full, the producer is not allowed to produce an item. So that is the main thing, restriction imposed on the producer. When it comes to the consumer is consuming the data, that is removing the data items from the buffer what that has been produced by the producer. So one piece at a time, whether when we are going to talk regarding the producer or when we are going to talk regarding the consumer, like producer has to produce a single item per time and consumer has to consume single item per time. Producer can't produce 5-6 items at a time and consumer can't consume 5-6 items at a time. Only a restriction is producer has to produce one item and consumer has to consume another item. So what is the problem you will be going to getting? The problem is to make sure that the producer won't try to add data into the buffer if it is full. So if this is the buffer, so in this buffer 3 slots are there. Here XYZ items are placed. Now producer can't produce anything. Producer can't produce anything because here the buffer is full. So producer is not allowed to produce the items. What is the problem? What is the solution for the producer in the sense? Producer either go to sleep or discard data if the buffer is full. So if the buffer is full, then producer will sleep. Producer will sleep in the sense, producer will wait until the buffer gets empty. Any one of the slot gets empty, the producer will wait. In this terminology, we call it as producer will sleep until this any of the slot gets empty. So the next time the consumer removes an item, so here if now consumer came and if he removes that Z item, then this producer wakes up and he will be going to start producing again. Until unless the slot is free, the producer is in sleeping mood only. When the slot becomes free, then it is an intimation to the producer that a slot is free, so now you can produce the item. So that is the coordination between the producer and the consumer. So how we are going to achieve this coordination in the sense, by making use of semaphores, we are going to achieve this coordination between the producer and the consumer. Fine. So solution for consumer is, consumer can go to sleep. When he has to go to sleep? If the buffer is empty. So if the buffer is empty, the consumer will sleep. If any one of the item has been produced in the buffer, then the consumer will wake up and he will be going to consume the items. Puts a data into the buffer, it wakes up the sleeping consumer. So this is how the producer and the consumer problem is going to be done. And by making use of semaphores, we will be going to solve this problem. So here the producer consumer problem is a classical problem that is used for multi-processes. You have to remember this one. It is used for multi-process synchronization, not for 2 processes or not for 3 processes. It is used for multi-process. But when we have seen the bounded buffer problem, that bounded buffer problem is only restricted for only 2 processes. We can't accommodate more processes in the bounded buffer solution. In order to overcome that drawback, what we have done is we have gone for this producer consumer problem. So what is the main advantage of producer consumer problem in the sense, like we'll be going to have the multi-process synchronization. So synchronization among the multiple process will be there by using this producer consumer problem with semaphores. Here we are going to solve this with semaphores. Fine. In the producer consumer problem, there is one producer that is producing something and there is one consumer that is consuming the products produced by the producer. The producers and consumers share the same memory buffer that is of fixed size. So the buffer is fixed here. If the buffer's capacity is 5, in the sense that 5 is fixed, we can't shrink that buffer size, or we can't increase that buffer size. The job of the producer is to generate the data, put into the buffer, and again start generating the data, while the job of consumer is to consume the data from the buffer. This is about the producer consumer problem. But what is the problem over here? But what are the problem we are getting here? In the sense, these are the 3 problems we have to, that might occur in producer consumer. The producer should produce data only when the buffer is not full. So only when the buffer is not full, that means if any free slot is there, then only the producer is going to produce the data. If the buffer is full, then the producer is going to sleep. The consumer should consume data only when the buffer is not empty. That means if any one of the slot is any one of the slot is full, then the consumer is going to consume the data. If the buffer is empty, then the consumer shouldn't consume the data. And the third important thing is, the producer and consumer should not access the buffer at the same time. So these are the 3 restrictions that we are going to have in the producer consumer problem. And how we are going to achieve this? We are going to achieve this by making use of a semaphore. So by making use of a semaphore, we are going to achieve this producer consumer problem. Here we are going to make use of 3 semaphores over here. So here we will be going to have the semaphore S. S is the semaphore, and semaphore E. 3 semaphores we are going to use, and semaphore F. These are the 3 semaphores we are going to use. What is the task of this S semaphore is, suppose here this is the buffer. Fine. So this is the buffer. So the task of this S semaphore is, so this S semaphore will be going to see whether producer has to do or consumer has to do. So this semaphore S is going to have the values of like 0 or 1. So if 0 in the sense nobody is using, 1 in the sense somebody is using. So this S is going to, why we are going to take this S semaphore in the sense, it is going to provide a mutual exclusion. So what do you mean by mutual exclusion? In the sense, out of 2 processes, that is producer and the consumer, only one should be there in this buffer. Actually, like here the producer will be there, here consumer will be there, here the buffer will be there. This buffer we call it as a critical section. Why this buffer we are calling it as a critical section? In the sense, this buffer is shared among the producer as well as the consumer. So where the shared items we are going to keep, we are going to place the shared items on the critical section and non-shareable items onto the non-critical section. Shareable items are going to be placed onto the critical section. As the buffer is going to be shared among the producer and the consumer, we are going to place this buffer onto the critical section, and this buffer size is fixed. Suppose the buffer size is n, that is also fixed. So why this semaphore is going to, SC is used in the sense, the S semaphore responsibility is to check whether only one is going to be there in the critical section, either the producer or the consumer. Only one should be there in the critical section. So that is the task of the semaphore. See here, the semaphore variable is used to achieve mutual exclusion. Mutual exclusion, the name itself indicates only one process should be allowed into the critical section. By using this variable, either producer or consumer will be allowed to use the access of this buffer. So we are going to give permission to the producer or to the consumer one at a time, though that responsibility is given to the semaphore S. And semaphore E in the sense empty. So this semaphore E, what is the purpose of this semaphore E in the sense? It is used to define how many empty slots are there. It is used to keep a count of empty slots. And the semaphore F is used to keep a count of full slots. Fine. The semaphore variable is used to define the empty spaces. So E is going to be used for empty spaces in the buffer. Initially, this E is going to set to 0. Why? Because initially no producer produced the item and no consumer consumed the item. So here this E is equals to 0. E is equals to empty slots. So here the empty slots is set to the, E is set to 1. N in the sense number of size of the buffer. N is nothing but the size of the buffer. Here producer not produced and consumer not consumed. So here N is the empty slots. How many empty slots are there? N is equals to 3 empty slots are there. And when it comes to the F in the sense full. Full in the sense initially no item is there in the buffer. So here full is equals to 0. If one item is there, we will be going to keep full is equals to 1. If two items are there, we will be going to keep the items as 2. If no items were there, we will be going to keep the full item, initialize the full with the 0. So these are the 3 semaphores we are going to use in order to achieve synchronization between different processes. By making use of semaphores, we are going to achieve. So let me tell you again, we are making use of 3 semaphore variables. Semaphore S is given the responsibility of making only producer or consumer to be in the critical section. Either of the one should be in the critical section. That responsibility is given to the semaphore S. And what is E indicates in the sense number of empty slots in the buffer. Initially no producer produced the item, so the all are empty slots, though that the size of that buffer is going to be initialized to the empty slots. When it comes to the full means if all the data items are there in the buffer, then full is equals to some 3, 4, 5 like that we'll write. If no data is there in the that items buffer, so the full is initialized with 0. So these are the 3 things you have to remember. Fine. So this is the basic introduction of using the semaphore.